Okay, so let's have a look at another AQA A-level physics question, this time a current electricity one about a thermistor. Right, so pause the video and have a look at the intro to the question. We've basically got what looks like a potential divider setup. We've got a thermistor which, as temperature increases, resistance decreases. We've got a variable resistor and an ammeter. Alright, so the resistor and thermistor is set up to make a potential divider. Explain what's meant by a potential divider. Okay. Now, I would initially have said potential divider divides up the potential difference, right? But the mark scheme doesn't accept the word divide, probably because it's actually in the word already. So you have to play nice with the exam board and say resistors placed in series in order to split up the voltage, allowing specific voltage to be achieved. So something like this would be fine. You know, since divide, I know what divide means, but yeah, that's the exam board being awkward because they think that the student could just guess at the answer just by looking at the name. But that's what a potential divider does, right? So if you're not sure what a potential divider does, let's just go back a second. If you've got two resistors, and they're 10 ohm and 10 ohm, and you place a voltage across them of 20 volts, you'll get 10 volts and 10 volts across each, right? It will share out the voltage like this. I won't say divide, it will split up the voltage like this, right? If you make this resistor 30 ohms, then what you get is, you get the voltages spread out in the same ratio as the resistances of the total resistance. So that 30 ohm resistance is 30 ohms out of a total resistance of 40 ohms. So you'll get 3/4 of the voltage, and 3/4 of 20, 3 over 4, or 0.75 in decimal. 0.75 of 20 is going to be 15. Okay, and so that means that would have to be 5. Right, so that's basically what a potential divider is, and that's how it splits up voltage. So we've answered that one. State and explain what happens to the voltmeter reading when the resistance is increased while the temperature is kept constant. Resistance is increased of R. So if we make this value bigger, okay, if we make this value bigger, so resistance gets larger, it's going to get more voltage across it, right? And not just following Ohm's law, right? Because V equals IR. So the voltage across this will increase, which means since there's only so much voltage to go around, the voltage here will have to decrease. So it does say state and explain. So there's two parts to it. If R is increased, then the voltage across R will increase in accordance with Ohm's law. So that's stating it, and then explaining it is, this means that the voltage across the thermistor must decrease in accordance with Kirchhoff's voltage law. Really, actually, mentioning Ohm's law and Kirchhoff's law, that's the explain bit, really, that's how you get those marks. Alright, so state and explain what happens to the ammeter reading when the temperature of the thermistor increases. So if you remember, the graph of the thermistor shows that, that's resistance in ohms, that it drops as temperature increases, okay? So basically, because the resistance of the thermistor is decreasing, the total resistance of the circuit is also decreasing. So as temperature increases, the resistance of the thermistor decreases, lowering the resistance of the whole circuit, and Ohm's law tells us that the current must increase if the voltage remains the same. Okay, so next bit. The battery has an EMF of 12 volts at a temperature of 0 degrees Celsius. The battery has an EMF of 12 volts at a temperature of 0 degrees Celsius. The resistance of the thermistor is this. If the voltmeter is replaced by an alarm that sounds when the voltage across it exceeds 3 volts, calculate the resistance of R that would cause the alarm to sound when the temperature of the thermistor is lowered to 0 degrees Celsius. Right, so we need to go back and look at the diagram carefully. So we're being told that we're going to replace this with an alarm, and that alarm goes off when it exceeds 3 volts across this. We were also told that the resistance of this is 2.5 times 10 to the 3 ohms when it's at 0 degrees Celsius, which is when you want the alarm to go off. So if we just look back here and remember, oh yeah, it's to do with ratios, that seems to be a quite straightforward way of doing this. We were also told that this is 12 volts and it's got negligible internal resistance. So if this is 12 volts, this is 3 volts, what must be the voltage here? Must be 9 volts, right? Okay. The ratio of this voltage to this voltage must be the same as the ratio of this resistance to this resistance. So I'll just set that out. 9/3 has got to be the same ratio as this resistance divided by 2.5 times 10 to the 3. Okay, and then it's a simple matter of rearranging for R. Multiply both sides by 2.5 times 9/3. Calculating this gives us a value of 7500 ohms. Okay, so basically 7.5 times 10 to the 3, and I think you can see this is 3 times larger than that. This is 3 times larger than that, so that's obviously worked. Okay, and in accordance with the way this thing works here, that should give us the correct split of voltages. So this is my working for that answer. I'm not going to put it in here because I don't have the space, but the answer would be 7500 ohms. Okay. Now, state one change that you could make that would make the whole circuit so that instead of the alarm coming on when the temperature falls, it comes on when the temperature rises above a certain value. Alright, so basically, currently, as temperature increases, the resistance of this decreases, so that the voltage across this thing is going down. If you wanted to do the opposite thing, if the voltage here is going down, the voltage here must be going up. So if you put the alarm here instead, what's the symbol for an alarm or a buzzer? Not sure. Let's just, yeah, so I'll just draw a speaker. So if you place your speaker there, well, it doesn't look like a speaker now, but anyway, I don't know the symbol for a alarm, thinking about it, or a buzzer, but if you place your component here, then you'll get the opposite effect. So that's all you need to do. It doesn't say explain, you don't have to do any extra stuff, it's just worth one mark, so that should be enough to get the answer. Place the alarm in parallel across R instead of T. Alright, thanks for watching, I hope you found this useful. Comment, like and share.